My name is Sean Hackenberg, and I'm a senior in computer science and math at Kansas State University. I'm working for Dr. Sheshiko from the Biological and Agricultural Engineering Department, and today I will be presenting our research on the development of a land use mapping framework at a subfield scale using a combination of georeferenced raster layers and county-based census data for Kansas. To give you some background on our research, various crop-related datasets are fed into watershed and hydrological models like AGNPS, SWAT, and HSPF, where crop-specific parameters are used to tune these models. Our research focuses on improving some of these common crop-related datasets to get more accurate results from the watershed and hydrological models. Specifically, the cropland data layer, a pixel-based land use classification dataset, and CARS, a vector-based field boundary dataset, which are often used in combination in these models. The objective of our research is to develop an upscaling framework that more accurately upscales the pixel data into these field boundaries. Current upscaling methods face problems from the misclassification of pixels in the CDL dataset and boundary areas in the CARS dataset. To address these issues, we developed two new upscaling methods, a mean threshold approach and a clustering approach that were then calibrated with NASS survey and census data on the amount of crops planted in a county each year. The mean threshold approach works by finding an optimal crop coverage threshold from the NASS statistics and then classifying fields with crop coverage above that threshold as that specific crop. The clustering approach works by finding fields with similar crop proportions and grouping them into three categories, a dominant, competitive, and unclear category. These categories can then be selected based on the amount of uncertainty you want to have in your classification of fields as specific crops. These two new approaches perform much better than the majority crop approach, which is the standard way of upscaling pixel data to field boundaries, with lower upscaling coefficients and better RMSE estimates of the acres planted value. Overall, the mean threshold approach provides the most accurate estimate of the survey values, but introduces some error by potentially having multiple crops assigned to a single field because of overlapping thresholds. The clustering approach offers more flexibility and the certainty you want in the classification of fields because of how you can select which categories of fields are included in the classification. The clustering approach creates a trade-off between classification certainty and NASS estimation accuracy by letting you choose if you want to include competitive fields which are less certain into your analysis. In the future, more work could be done to refine field boundaries in the CARS dataset by examining fields within the competitive category, and additionally, pixel-based spatial clustering could be done to remove some of the misclassification in the CDL dataset. Hopefully this research contributes to more reliable agricultural and hydrological modeling, benefiting both scientific understanding and local land management practices. Thank you for your time.